Hello, welcome to Maths with EJD. In this video, I'll be talking about identifying outliers with interquartile range. As you can remember, interquartile range is actually one of the measures. It's one of the measures of dispersion of variability. Dispersion of variability. The rest range, variance, standard deviation. So, and one important thing about interquartile range is that it is very good. I mean, interquartile range. One of the advantages of interquartile range is that it can help you identify outliers in a data set. Now, it is necessary to identify outliers because uh, be it in data analysis, data science, machine learning, and all that, there are times you need to pre-process your data to be sure it is fit for purpose. And one of the things you might want to do is to take care of outliers. So an interquartile range helps a lot in that regard. It's one of the methods definitely of handling outliers. Okay, so let's talk about that. Outliers, outliers are data points that are significantly different from the rest of the data set. Imagine as an HR person, you're going through the company staff list, and then you have their ages and all that, and then you find somebody who is like 72 years old, or you find someone who is 15 years old. Of course, it may be mistakes that you have to correct, and it may not actually be. It's just be that the 72-year-old person is actually the founder of the company who is still on the payroll, and the 15-year-old or 17-year-old who is not an adult can just be, somebody, maybe the owner's grandson or whatever. But of course, when you see things like that, you want to find out what exactly is happening, because normally you don't expect anybody below 18 or anybody above 65 or 70, as the case may be, to be working in a company like that, because anything above 65 or 70 is retirement, and anything below 18 is not yet mature enough to work there, right? So, but if you want to handle outliers, if you want to detect and deal with them, interquartile range is really useful in that regard. So let's go. So the interquartile range, that is IQR, is a common method. Is a common method to detect these outliers. So the IQR is calculated as the difference. We did this under measures of dispersion. So the IQR is calculated as the difference between the third quartile, Q3, and the first quartile, which is Q1. All right. So that means that IQR is actually Q3 minus Q1. Okay. And of course, Q3 and Q1, they both have their formulas. In case you've not seen the video on measures of dispersion, you want to check that. Of course, I'm still going to refer to that here actually. So let's see how that goes. So what is the connection of outliers with interquartile range? Outliers are typically defined as data points that fall below. So any value that falls below the first quartile minus 1.5 times the interquartile range is said to be an outlier. So outliers are typically defined as data points that fall below Q1 minus 1.5 times IQR, or any data point that falls above Q3 plus 1.5 multiplied by the interquartile range. So this will be the two definitions. So I like the two. So any value that falls below this Q1 minus 1.5 times IQR, or above Q3 plus 1.5 multiplied by IQR, would be seen as outliers. Okay, so let's use both grouped and ungrouped data to check for some outliers, for instance. Okay, let's start with ungrouped data. Ungrouped data. Okay. Consider the following data sets representing the ages of 15 participants in a survey. And the values are 22, 23, 24, 25, 28, 28, 30, 32, 35, 36, 40, 45, 50, 70, and 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you have those 15 values, right? So does this data set contain some extreme values? That's the first question. The second question will be something like, if yes, what which of the values are extreme or are outliers? Okay, each of them are outliers. So that's the question we have here. So how do you do outliers again? Don't forget, of course, you outliers, you already know. For outliers, first of all, you need to find. Okay, let me just refer to this instead of having to write it again. So any value that falls below Q1 minus 1.5 times IQR, and any number that falls below Q3 plus 1.5 times IQR will be outliers. So it simply means that you need to know Q1, Q3, and IQR. Okay, so let's go. The solution will be something like this. First, find Q1. Q1 is the first quartile. And how do you find the first quartile? It's actually, the first quartile is actually sorry, the first quartile is n times 1 over 4. Okay, n times 1 over 4. Or better still, the first quartile is 1 over 4, that's it's the 25 percentile. 1 over 4 times n plus 1. Yeah, 1 over 5 times n plus 1. So it will be the 1 over 4 times n plus 1th value in the data set. That's how that goes. So from what we have, right, the data has 15, the data set has 15 values. So n is equal to 15 for sure. So the first quartile would be 1 over 4 times 15 plus 1. I mean, the okay, that's the position the data occupies actually. It's actually the position the data occupies. Okay. So that you now have Q1 to be 1 over 4 times 16 over 1 position, meaning that Q1 is actually the number in the fourth position. Of course, you have to arrange in ascending order, strictly ascending order. So, 4 here is 1, 4 here is 4. So, the first quartile is the number in the fourth position. That's 1, 2, 3, 4. So, this is your Q1. Okay. Q1 is 25. Q1 is 25. So, for Q3, so that's you have found Q1 now. Now let's find the second step is to find Q3. And just like Q1, Q3 would just be 3 over 4. That's the third quartile of the 75th percentile times n plus 1, whatever this is, position, as a position that the third quartile is. So Q3 is equal to, of course, n is 15. So that's 3 plus 1. 3 over 4 times 15 plus 1, which is 16 over 1. And that's a position that is going to occupy. So 4 here is 1, 4 here is 4. So Q3 occupies the 12th position. Occupies the 12th position. So let's go by the 12th position. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So at the 12th position, you have 45, and that is your Q3. So the third quartile is actually, is that the 12th? The third quarter, yeah. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 1, 2, 3, 4. What did you get at first? Yeah, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, the number in the 12th position actually, except is something wrong here? 3 over 4. Yeah. The number in the 12th position is actually 45. 45. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 45, 13, 14, 15. Yeah. So the number in the 12th position is 45. All right. So that's Q3. So the next step is to find the IQR, the interquartile range. So step 3, find IQR. So, and simply, we know that IQR is Q3 minus Q1. So Q3 is 45. Q3 is 45 minus Q1. Q1 is 25. Q1 is 25. And that is 20, right? So IQR is 20. IQR is 20. Okay. So since IQR is 20 now, we can get the compute the, should I say, the limits, compute the limits. The limits are 2. So the lower limit, or rather, yeah, we can say bound, right? Yeah, limit is bound, right? So let's talk about the lower limit. The lower limit is Q1 minus 1.5 times IQR, which is Q1 is 25, right? That's 25 minus 1.5 times IQR is 20. Okay. So we have 25 minus 1.5 times 2.0. That's 15 times 2. 15 times 2 is 30. 15 times 2 is 30. that is -5. Okay, so that is -5. So that is -5 for the lower limit. So let's talk about the upper limit. The upper limit, is Q3 plus 1.5 times the IQR. So that means Q3 is 25 again. No, Q3 is 45. Q3 is 45 plus 1.5 times IQR, which is 20. So that is 45 plus 30, and that is 75. Okay. So what that simply means is that, so therefore, any data point, so we say that any data point below -5 and above 75 is considered an outlier. So any data point below the lower limit and above the upper limit is considered an outlier. And from what we have, right, so does this data set contain some extreme values? Yes, right, because we have 100 here, which is above. So we don't have anything below -5, but we have something above 75. So the first part is 100. Okay. The first question is, are there any extreme values? Yeah, there is an extreme value, that is a value above the upper limit, which is 75. All right. So the second part is asking, if yes, which of the values are outliers? Okay. We have only one outlier. That's 100. 100 is the only number above 75. Okay. So there's an extreme value, of course, that is a value above the upper limit, which is 75. So the outlier is 100. Okay. Because it's above 75. The outlier is 100 in this case. Okay, so that is for ungrouped data. Let's go for grouped data. Let's go for grouped data and see how that works. So we have grouped data now. So let's use a grouped frequency table, representing the weekly salaries, of 50 employees, in a company. Okay, and this is the table. We have the salary range, and then we have the frequency. So 200 to 299, we have 5 people earning that. 300 to 399, we have 8 people earning that. 400 to 499, we have 12 people earning that. We have 500 to 599 with 10 people earning that. We have 600 to 699 with 7 people earning that. Then we have 700 to 799. We have 4 people earning that. We have 800 to 899 with 3 people earning that. And lastly, 900 to 999. One person earns that. maybe the CEO or something. So we have this. Okay. So this is grouped data, right? Of course, as usual, we don't know if there's an outlier, right? We just want to find, uh, we want to check if there are outliers. So check for outliers. Check for outliers. That's all we want to do. So, of course, the first thing is find Q1. Now, for grouped data, the formula is not as straightforward as the other one. So here now, we need to know the number of data points, which is 50, right? That's the total frequency. Okay. In this case, we need the cumulative frequency, which I can just do by the side here. So I don't duplicate the table. Okay. We need the cumulative frequency. So, of course, we've been told there are 50, so we don't have to worry. So this is the cumulative frequency. So this is 5 here. Then 5 plus 8, 13, 13 plus 12, 25, 25 plus 10, 35, 35 plus 7 is 42, 42 plus 4 is 46, 46 plus 3 is 49, 49 plus 1 is 50, as expected. So it means n is 50. Of course, before we even start talking about all the n and everything, okay, this is 50, right? So before we start talking about all the n and all that, we should know the formula for Q1 for grouped data, right? So Q1 for grouped data is actually the lower bound, of the first quartile class of the Q1 class. So I can say LQ1 plus n times first quartile, right? That's 1 over 4, n times 1 divided by 4 minus the cumulative frequency before the frequency before the first quartile class, if you like, times the class with H over the frequency of the first quartile class. So I'm adding the Q1 just to indicate what all of that should be. So first of all, we need to identify the first quartile class. Okay. So we can easily do that by just doing 1 over 4 times. So it's like this part takes care of that. 1 over 4 times 50. So that's 50 over 4. That's 25 over 2, which is 12.5. So the quartile class is here. So this indicates wherever the cumulative frequency is 12.5, that is like the first quartile class. That's the Q1 class. So let's go and see where do we have cumulative frequency of 12.5. Okay, first one is 5. Second one is 13. So 12.5 is inside this 13. So this is actually the Q1 class. Okay. This is the Q1 class. Okay. So we have identified the Q1 class to be 300 to 399. The Q1 class is 300 to 399. Okay. So that the lower boundary of the Q1 class is simply 300. That's this 300 now. And what else do we need? We already know n is 50. N is 50. We already know that. That's the total frequency or the last cumulative frequency, if you like. Then the cumulative frequency before the Q1 class, this is big F now. Before the Q1 class, that is the Q1 class is 13. The cumulative frequency before it is 5. This 5 here. Okay. So that is 5. That is 5. That's 5. What else do we need? We have the class with H. That's like, of course, it's regular. 399 minus 300. That is simply 99. That's the class with. And the last thing we need is the frequency of the Q1 class. That is the actual, this is small f now. This is, big F is cumulative frequency. Small f is the actual frequency of the Q1 class. So the frequency of the Q1 class is this 8. Okay. So this is 8. So we can get we can now go for Q1. So Q1 now is 300 plus what do we have up there? N times 1 over 4. That's 50 times 1 over 4. Minus cumulative frequency before that place. That is actually 5 times 99 over the frequency of that class. That's 8. So we need to compute this now. Okay, so Q1 is equal to 300 plus 50 over 4 is 22.5, like we got before, minus 15 times 99 over 8. So that Q1 is equal to 300 plus 22.5 minus 5 is actually 17.5 times 99 over 8. This can be together. So we have Q1 to be equal to Q1 is equal to 300 Q1 is 300, right? Plus, let's compute this. So 17.5 times 99 over 8. 17.5 times 99 over 8. Let me quickly get this out. 17.5 times 99 divided by 8. That is 216. This is 216.5625. Okay, let me do that again to be sure. 99 divided by 8. Okay, that's 12.35. 375. Okay, that now plus okay, 12.375. 12.375 plus 17. Okay, times now. Times 17.5. Yeah, 216.5625. Now, so it means that Q1 is simply 516 points. That's 516.5625. So that is Q1. So we need to find Q3 now. So let's find Q3. To find Q3, again, Q3 would be the lower bound of the Q3 class plus n times 3 over 4, because the third quartile is the 3/4 class, and as the frequency before the Q3 class, the cumulative frequency, that is, times the class width divided by the frequency, the small frequency, the actual frequency of the third quartile class. Now the question is, what is the third quartile class? So to find that, use this part. So you have that's 3 over 4 times 50. That is 150 over 4, right? That's 75 over 2. That is 37.5. So this tells us the Q3. This tells us the Q3 class. So wherever the cumulative frequency is 37.5, that's our Q3 class. So let's go. 37.5 is what we're looking for. So 37.5 automatically falls here. So 37.5 falls here. That is 600 to 699. So 600 to 699 is the third quartile class. So 600 to 699 are the third quartile class. Okay. Automatically then, LQ3, the lower bound, will be 600. Then, of course, we know N is 50 already, right? N is 50. FQ3, that's the cumulative frequency for the third quartile class. That will be, what's the cumulative frequency before that point? That is 35. So we have FQ3 is 35. Of course, H remains 99. That's 600 minus 699 minus 600. Then the frequency of the third quartile class the frequency of the third quartile class is actually 7. Okay, that's 7. So with that, now we have everything we need to compute the Q3. So Q3 now is 600 plus 50 times 3 divided by 4 minus FQ3, that's 35, times 99 divided by 7. So Q3 is equal to 600 plus 50. Of course, 50 times 3 divided by 4. That's not our first number of singles. That's 37.5 minus 35 times 99 divided by 7. So we have Q3 to be 600 plus 2.5, I believe. Yeah, 2.5 times 99 divided by 7. So let's go for that. 99 divided by 7, that is 14.1428 times 2.5 times 2.5. So that is 35.3571. So Q3 is 600 plus 35.3571. So it means that Q3 would be 635.3571. Okay, so that is Q3 right there. So next we go for IQR. So we want to find IQR now. So to find IQR, so IQR we know is interquartile range, right? Which is Q3 minus Q1. So Q3 is 635.3571 minus Q1, which is 516.5625. 516.5625. Okay. So IQR now would be so IQR is 635.3571 minus 516.5625. So that is 118.7946. Okay, that's the IQR. So now we need to find the lower limit. To find the lower limit, of course, you know that lower limit is equal to Q1 minus 1.5 times IQR. So the lower limit again is 516.5625 minus 1.5 times IQR is 118.7946. 118.7946. Okay. So that is equal to okay, 1 point, so I'll do 1.5 times okay, let me say minus 1.5 times 118.7946, and that's now plus 516.5625. So that gives us 338.3706. This is the lower limit. Okay. Then we go for the upper limit. So to find the upper limit, to find the upper limit, so we know the upper limit itself is the third quartile, Q3, plus 1.5 times IQR, right? So that is the upper quartile now is 635.3571. 635.3571 plus 1.5 times IQR. 1.5 times IQR, that's 118.7946. 7946. So again, we have, so I'll start with the multiplication. I have 1.5 times 118.7946 plus 635.35.3571. That is 0.3571. So that is 813, 813.549. Okay. So now the question is want to check for outliers, right? So the lower bound, okay. Outliers will be below 338 point will be below 338.3706 and above 813.549. Okay, that's what we'll have outliers. Now let's check the table. Do we have such values? So yeah, so it means that anything below 338, below 338.3706 and above 813, 338.813. So let's look at the table now. So from this table, that means there are some values here, there are some values around here that are outliers. There are some values around here. So from here up to this, those will be outliers. Okay. Then 813. So it means from 813 upwards. So if you have 813 somewhere here, down here, these are outliers. So we can see that from the table, right? We can make this conclusion. From the table, there are some outlier values, Okay, I guess I need to label the classes for easy referencing. So we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 classes. So there are some outliers in the first and second classes, as well as the 7th and 8th classes. Okay, because of the limits we have. So from the table, there are some outliers in classes 1, 2, 7, and 8. And that's where that all ends. So, and usually to handle outliers, if you want to make your table such that there are no outliers there, what you may need to do is to make sure anything you trim down every number above the upper limit, you bring it down to the value of the upper limit, and every number below the lower limit, you bring it up to the value of the lower limit. That's usually what is done. I mean, we get to do that a lot in data analysis, data science, and all that. Okay, so we've been able to detect outliers using the IQR method, using for both grouped and ungrouped data. And on this note, I must thank you for being here up till this point. If you have not subscribed to this channel, be sure to do that. And of course, hit the notification bell so you can always get alerted when a new video is released. And don't forget to comment, like, and share. Till I see you again, stay good. Bye.